Okay, so let's look at question number one here, where we are going to test for independence or dependence in this chi-squared problem. Okay, so the first thing we've got to do is amend this table right here. And what I mean by amend it is we need to add up the rows and the columns so that we have totals. So let's see, this is going to be 38 down here. And what is that? That's going to be 51. And I'm just going to make a little slash mark here just so we keep them apart. And this is going to be 66. So there's the totals for these columns. Now I'm going to total going across. So let's see, 14, 24, and 33 is 71. And then 24, 27, and 33 is 84. And then I want the total for both of those rows added together or all of the column totals added together. It should be the same amount. And that's 155. So the final total, I'll put it over here, is 155. Okay, so now that I've got the totals for the columns and the totals for the rows, we're ready to do this expect frequencies down here. All right, so what I'm going to do is for 14, I look across to the row total that corresponds to 14, that's 71, and I look down at the column total that corresponds, that's 38, and I take 71 times 38 and I divide that by the complete total, the 155. Okay, so if I do that, 71 times 38 divided by 155, I get 17, and let's see, does it say what to round to? Three decimal places. 17.406. All right, now same thing for Y. I'm going to, the row total that corresponds with the 24 is the 71. And if we look down at the column total, that was 51. So it's 71 times 51 over 155. Twenty-three 0.361. Now I'm kind of going out of the boxes here, so this really belongs in the second box, in this box right here. All right, now I'll do this one. All right, so if I look at the 33, across from it is 71, and down at the bottom of 33 is actually the 66, just because of my writing here. That should be the total for these two columns. So it's 71 times 66. Divided by 155. And that ends up being 76, so this really belongs in this box. 76.039. Now we're going to do the exact same thing for the next ones. I won't write them out as I did here, but we're going to do, okay, so for 24, across from it is 84. 84, and the column total below is 38. 84 times 38 divided by 155. And that is 212.80. I'm going to do that one more time. 38 times 84 divided by 155. Oh, okay. Yeah, I thought my answer was a little strange. So this is 20.594. All right. Now, let's do the next one. So if I look at the 27, down below it was the 51, and out to the right is the 84. So 84 times 51 divided by 155 ends up being 27. Oh, I hate it when it does that. Let me see if I can fix it here. Okay. 0.639. And then lastly, of course, this is actually the one that goes in that second box. I'll sort of put it out here going in this last box. We have the 33, so that's the 66 below in the column and the 84 over in the row. So 66 times 84 divided by 155. And that ends up being 35.768. Okay, now for our test statistic, it's somewhat tedious. Okay, I'm going to do just a few of the terms, and then after that, I'll give you the answer rather than trying to write them on this screen very slowly. But what we've got to do is take the two charts now. We're going to take the X value that's in this first cell, 14, right here, minus the one that's in this cell. So we're going to do 14 minus 17.406. We're going to square that and divide by the 17.406, the second one, the one that's in our expected frequencies. Okay, so we're going to do that for every single cell. So we'll now have 24 minus 23.361 squared. I'm going to try to stay on the screen here. I know that looks funny. Over the second one, 23.361. Now you get the idea. I've got to do that for every single cell and add them all up. All right, so I'll have to do 33 minus 76.039 squared over 76.039. And then I'll have to do 24 minus 20.594 squared over 20.594. And then I'll have 6 of those calculations to add up. Um, so Now, I'm a little concerned by this 76 since it's bigger than this 35. I'm going to redo that calculation real quick. Let's see, I should have done 71 times 66 divided by 155. Let's just make sure that that was right. It's not. Okay, so my feeling there, I must have made a silly mistake. Let's fix that real quick. So that way, when you do your calculations, you know, okay, there was a mistake there. And it's real easy to make. If we get a much bigger number than some of the others, we might want to look at it again, which is what clued me off there. All right, so on a separate sheet of paper, I'm going to do all of these calculations and we'll write down our test statistic. That way you can check yourself, make sure you're doing everything right. I am going to have to exit this, so before I do, I will write down all of the new calculations. Because unfortunately, when I go out of draw, it loses everything. Now, you, of course, as you're looking at the video, can rewind, but I can't do that while I'm taping the video. Okay, so, um, after that very tedious calculator calculation, I get 1.72968. And doesn't tell us what to round to. I think they're rounding to 2 decimal places, but I'll write out the whole thing here. I got 1.72968. Okay, now let's find the critical value for this test. Now, all chi-squared tests are right-tailed. So when we look up this critical value, which we'll go ahead and do it on Excel instead of on the table. We'll do it in Excel. Um, we want this to be able to be to the right, to be in the rejection region. It has to be to the right of this. So we'll see if it is. All right, so we've got a significance level of 0.10. We have to get our degrees of freedom. Now, the degrees of freedom, if we look at the rows, we have 2. So to get our degrees of freedom, we do the number of rows minus 1. So 2 minus 1. And the number of columns. And we want to make sure that we don't include total columns. So, you know, those are separate columns without totals. So 3 minus 1. So that's 1 times 2. So our degrees of freedom are 2. So we have 0.10 as our significance level and 2 degrees of freedom. Let's go ahead to Excel. I'm not sure if I've got Excel open. Oh, I have to exit drawing. So let me write down 0.10 and 2 degrees of freedom. And I have to exit the drawing. Okay. And here we go. So we're going to do equal chi-square.inv, and we're going to do 0.10, 2 degrees of freedom. Oops, something I must have typed wrong. Let me do it again. Let's just do chi inverse. I didn't think I had to write that square. 0.10, 2 degrees, and there it is, 4.605. 4.0 or 60. I'm going to write that down. 517. So our chi-squared critical value here was 4.60517. And let's just recall that this was 1.72. Oh, my writing is just kind of horrible on this. 968. Now I said it's a right-tailed test. So this number right here has to be to the right of 4.6, which it's not to the right. So that means we cannot reject our null hypothesis, and our null hypothesis is that the um, the variables a and b and xyz are independent. So let's exit the drawing here so that I can actually scroll down. So there's not sufficient evidence to support the alternate, which is that they are dependent. So we want to choose this one. There is not sufficient evidence to support the claim that the row and column variables are dependent.